Hello, everyone. Happy to be here. I'm not first time in Pydata, but first time in Pydata London. So that's exciting. Today we are going to talk about data context, how to give data context to your agents, and actually it's very useful for people as well. So two main venues for the talk. One is a SQL, how to do this in a SQL. It will be based on some publications. It's not like my work, but my area it's unstructured data. How to do this with three files and three storages, and how to do this in a Python instead of SQL. So I work with data, structured data for more than 10 years. I was data scientist at Microsoft, Bing, for almost 5 years. Then I created open source tool DVC. If you know this, DVC is a Git for data. And now we are working on DataChain. It's kind of the next iteration of the tools for data, unstructured data specifically. I will talk about DataChain in part of the talk, like how we implemented this context extraction for the agents. So, and I believe many of you are using different types of coding tools, right? Like Cloud Code, PI, Codex, whatever, right? Because everyone uses. And so in some area, it disrupted workflow a lot, right? In the front-end development, sometimes in back-end development. But if you talk with the data teams and ask, okay, how much it improves your life, how much you become efficient with these tools, they usually say, yeah, that's really helpful, maybe 30%, maybe 50%, but it's far, far away from this a 10x marketing when people are saying, oh, that's the way to be 10x productive. And people think about this, okay, we understand data is special, right? That's why it doesn't work. But in fact, I'll show you an example. It does work. There's a tremendous improvements of team performance. And the only thing you need to do this to enable these improvements is to provide context, data context to your agents. And absolutely the same agent, the same harnesses like Cloud Code or Codex will give you a way better result that's default ones. So yeah, same models, same harnesses. It could be a way better result in terms of code they can generate and insight, how fast you are getting insight from your data. So we kind of got lucky that Frontier Labs start talking about this, how to provide context to the data context to the agents. In January was published a blog post from OpenAI about their in-house data agents, how they do this job. And when I was preparing to this talk, this week, it was on Wednesday, Anthropic published their blog post about this, how they build their agents for Cloud Code. So the first part about SQL, I will be referencing to those blog posts and kind of get an insight from this blog post. And the second part would be about what we do with DataChain, about unstructured data, and how we kind of dealing with the same set of problems, right? And I will be talking about the core principles that's pretty much universal among the folks who are building these tools. So Anthropic blog post very interesting because they publish a lot of metrics, how much it improved their accuracy and different other metrics. And they claim that with context, their agents' efficiency, accuracy increases from 21% to 95%, right? That's a lot, you can imagine. So it means most of the problems, most of the questions to data could be easily answered by Cloud Code, right, if the context is there. And those are core principles that, first of all, we are dealing with, right? And while working with unstructured data, at the same time, when I read this blog post from these companies, I see they kind of discover the same problems. They come up with the same similar solution to this problem. First is how to discover data, the obvious one, but at the same time, the most fundamental one. How to type and how to kind of classify your different data assets, which one you should believe to or which one you should probably not. Then lineage. Lineage plays very important role in data team, right? If you deal with the data, you know like how important it is. With the agents, the role is very different, because with the agents, it's not like a good thing to have, it's a must-have thing. Without data lineage, of course, agents cannot do the proper job. And how to deliver this? That's just kind of like logistical question. So let's go quickly through these papers, right? How they deal with this. So discovery. In one interview, they were saying like, okay, we are dealing with 70,000 of tables. Like writing SQL is not a problem, but how to know which table to take, right, to solve the problem. And the good news is, if you deal with structured data, you have data warehouse, right, or something similar. So tables are there, you just can list the tables. But that's only half of the problem. Another part of the problem, all this information needs to be like constantly updating. And Anthropic claims that their accuracy drops from 95% to 65% in one single month if they don't update the meta informations about tables and such, right? So drastic accuracy reduction just because data is not outdated. So it has to be like automatic process of doing this. So types, schemas, and all the stuff. The same problem, right? You need this information, like how to join the table, like what you can take from the tables. And part of this information are already in the table. That's good. What is not there, you don't know which tables to trust more than the others, because you might have like in OpenAI, they're saying we have like, I don't remember the number, like 15 or something definition of revenue, right? I believe every organization has this problem, right? Which one to pick? And agents are usually like an LLM. They're kind of like very aggressive and how to say over optimistic, right? They can easily take like any table which fits and throw a solution to you based on this table. So you need to differentiate like the tables you really believe in from the others, right? And both of the company come up with this kind of like semantic layer. So basically they're saying these tables we believe in, the others like we are not sure about. And also Anthropic publishes a very interesting number that if they give like access to whole universe of the tables, the accuracy improvements is less than 1%. And you can imagine like how much tokens it will take extra, right, to deal with this huge amount of information. So lineage, it's about like not only data dependency but also code dependency. In OpenAI, it's very clear messaging. Code is like everything, because code, it gives them a lot of context, a lot of like enrichment they're getting through the code, and they do like a daily updates of like populating like all this information about their data tables and everything, right? Anthropic, they also, of course, need all the stuff, right? But they take a bit different approach. They inject provenance footer to each data set. Like where data came from. Is it from a semantic layer or some random table? How fresh it is, who is the owner, et cetera, et cetera. So, and of course, source code. Source code is like everywhere. It's like just must have. So without this, you won't get like such a good result. And delivery problem, that's like kind of more like obvious one, logistical one. Difference is not so big, I would say, but OpenAI, they work mostly like through MCP, like standalone like an agent somewhere, right? And they deliver this to Codex and ChatGPT through this standard protocol, right? And they update it on a daily basis. Anthropic does takes a bit different approach. It's a skill for cloud code. It's based on MD files. It's all in your repository. I mean, not your, but theirs. Repository, and they update it in every single PR. They have like some hooks in order to update it and kind of support this data consistency. So that's basically the table, right? How the set of the problems. So Warehouse gives you table schema, good. It needs to be updated. You need to classify data like major tables from the other tables. Lineage here, MCP skill, kind of the tool set how to build this data context for the structured data. So, but I'm living like a little bit in a different universe when data warehouses like do not exist. Most of our user customers, they have video, sensor data, some robotics data in S3 or Azure storages. And of course, there are no catalogs, no schemas, nothing, just set of files. That's it. And source code like somewhere like in their repositories. But at the same time, to be able to answer all those questions, right, to make agent efficient, we need to kind of solve the same problems. And we are working on this in the past like a 6-9 months and faced pretty much the same set of challenges that people from structured data world. But at the same time, we need to kind of like get these like data warehouse capabilities in order to make some kind of like foundation for this, like something like analog to the schemas, to the tables, how to operate with them. And so like I'll show you like how we do this in a DataChain. And if you deal with the unstructured data, so very likely you kind of come up with like similar workflow and very likely using Python, right? So, but first, before we jump here, I wanna show you like what we need to achieve, right? So, and we need like a very simple thing. We should be able to get some kind of skill or MCP or whatever, right? With the context, give it to the agents, and our agents should be able to answer some more interesting question, right? So with DataChain, you just install the skill. Well, run cloud code. It might be not cloud code. It could be like other like Copilot or something, right? And at the end of the day, you should be able to answer some more like interesting questions about data. For example, like this one, right? So I have a bucket or some directory in a bucket with images, and I have like image of my dog. I need to find not just dog similar to my dog. It would be like boring, right? Like a one-step operation. Data problems usually like multi-steps. But also we have annotations, maybe some JSONs next to images, right? Usual problem. It has the annotation have meta information. We need to filter out images only with the mask. We need to remove some specific types of images. And also, image size should be like more than 400 pixels, right? And usually, like it goes on and on, right? It becomes like multi-steps data problem, right? They're just not tables, so we are dealing with the unstructured data, but the set of problems are the same. So it will work. I'm not sure we have enough time for this, but I have final result somewhere. I'll show you anyway. So how we deal with these problems? We need to have these tables as a foundation. We need to have schemas as a foundation. But how we do this if only Python is available, only files on S3 are available? And we kind of come up with these abstractions. We invented the abstraction of datasets. We put it on dataset DB. So you can point to some directory and filter files by some criteria and create a dataset, right? Like save these pets. It creates version 100, and it goes to the dataset DB, so you can operate with those datasets. And usually it's not enough. You need to kind of enrich data somehow, apply some model, run LLM with some prompts, or do some filtration. You need to basically run some Python on top, right? And those like mappers, we are obviously implemented for that. So you can enrich like with any information and put on the same data set. So this data set becomes kind of like a table analog in the structured data world. And under the hood, it's actually a table. And with dataset, you need like whole like algebra of operations with this, right? What change? Div of dataset, union of dataset, right? Different types of join. How I join this like embeddings of images with JSON files we read from the other directory, right? You need a lot of different operations. And at the end of the day, how it should look like? It should be the whole set of, oh, it's small, whole list of data sets, right? Like this one. A lot of different data sets with all the information you need. So pretty much what you have in the database. So we can update this properly and give this information to agents, and agents can reason based on this data sets. So they can reason based on like millions of files you have in your bucket. And that's only first part of the problem, right? It's only discovery problem. And we already need this invent data set for that. The second problem is the schema. OK, we got the images. We run some LLM or some model on top. But we need to understand like what is the schema for these signals. And sometimes schema is like complicated. And the invention was like straightforward. Why don't we use like Pydantic as a schema for not structured data for Python? So when you run the Python code like this one, get info, you just specify what you need to return, and it has to be a Pydantic schema. It can be like very simple like this one, like with 2 integers. Or it could be like super complicated, like LLM response, which has like dozens of columns, list of objects. Each object has like a whole its own hierarchy of fields. But the interesting part is like we should be able to get it and use it as in our tables, right? And under the hood, what we do kind of like we have a whole transpiler to transpile this like a Python Pydantic thingy to the database table. So because we need to work on a database scale, on a database speed, and be able to work with like millions of files. But all this information also gets to the this catalog of datasets. So in addition to dataset itself, pointers to the files, right? Like here, you might have a lot of different additional fields, right? Like size of the images, some meta information you extracted from from annotation, right? Like here, like a mask. And that's kind of form the whole schema, rich schema, and rich data sets, right? And we have even separated different types of data sets. So this is like when you separate like an important data set from the other data sets. We have like whole like methodology built into the skill to have like a foundational data set, I would say. So you can reason on top of those. And the other data set you probably should ignore, so not to overpollute your context window. So example is here. If I put this like a prompt to find like a similar doc, right? It starts like reasoning. It starts splitting the problem by steps. And if step is general enough, it creates like a separate layer, what we call like a layer 1, layer 2, or 3. Like for example here, it computed all the embeddings and put embeddings separate data set. So next time, if you ask similar question, I need to find like a doc similar to other docs and with a different characteristics, right? So it will start using like pre-computed embeddings right away, right? So that's kind of like you separate this kind of like semantic layer from the regular tables questions that you might have like millions of those. And the lineage. Lineage, as I said, it's just must-have. You agents cannot reason without it, right? So all the relationship between data set needs to be presented somewhere. So here is just a simple hierarchy of like 3 layers, right? One data set depends on like 3 others. Everything goes to the bucket. In reality, it might be more complicated. So in the previous example with the dogs, it also had two data sets, right? One is clip embeddings. So, and you can take a look at this embeddings, the source code which generated embeddings, like everything, right? And at the end of the day, it goes to the bucket, to the storage. And delivery process, nothing unique here. We deliver it to this through the skill and MCP skill. It's kind of like an open source version, right? You can take a look at our skill in the repository, and it uses like local database. You see like in the center, it's a database with all the meta information, right? Database creates like a knowledge graph. That's basically like API with the agents. So agents doesn't go to database directly. It uses like enriched agents-ready information, right? OpenAI does the same. They do like LLM enrichment for the agents to make them more efficient. And compute engine, that's more like a Python not structured data specific, because you have to run the stuff, and it goes to the storages as usual, right? So question now is, does it give us like 10x performance improvement for us, for our teams? And I think it's still kind of like an open question, and I don't think like we should push specifically for this like 10x improvements, but based on our study, we have done like some internal study, and hopefully it will be published soon. But the numbers we got varies from like a 3x to like 8, 9x in terms of like how fast we can get result, or how much money we spend on some operations, especially when it's failing, and the cost of recompute. The difference is tremendous, because first of all, if you like compute some result and put in a cache, obviously it will be like very efficient. Obviously you are saving a lot of money if you're reusing this cache over and over again, right? But in the world of unstructured data, especially when you use LLM, right, and each kind of like compute step requires like a external call plus tokens, etc. This difference become not 100x, not 1000x, but sometimes it's hundreds of million x, comparing to like redoing this work over and over again. It's kind of obvious, but at the same time, this like numbers become like very interesting, because LLMs, expensive LLMs are involved. So the same table, and one part contains like the result from the SQL world, and another one from unstructured data world from the Python. So discovery based on the tables, or you need to invent tables, like that's what we have done, right? Tables needs to be updated, always fresh. Types, you either have this types in the database, or you reinvent the types. So we have done this with Pydantic and Transpiler, but at the same time, you need to understand what data sets are important, what are not, right? So you kind of like need some classification of data sets, and lineage, data set dependency, table dependencies, source code, that just has to be presented to the agents in a consumable way, usually through some LLM enrichment in this process. And delivery process, obvious, very standard skill or MCP or both. That's how your cloud code or API or codecs understand the context, and that's how how you can become like more productive when dealing with the data. When your agent knows about your data, can answer interesting question, can reuse your cache compute, which was done by you or your teammates. So that's pretty much the ideas we have and experience we got while building this data context layer for structured data. So happy to answer your questions.